Hello everyone, welcome to another video from Advanced Math Tutors. Today, on our series called Alternative Math, I want to present to you two correct solutions for the garden problem. The garden problem can be a misleading problem, and a lot of students arrive at the right answer but for the wrong reason. And so the garden problem is a gardener has two plots of garden. Each plot is divided into 5 equal sections. If the gardener plants roses in one section of each plot, what fraction of the total garden did the gardener plant roses in? And the conclusion that a lot of students come to is that they see 10 sections and 2 of them are colored in. So these red parts is where the gardener planted roses, this one and this one. So there are 2 shaded sections and 10 total sections, so the answer must be 1/5. And that is actually the correct answer, but this is not the correct reasoning for how you can arrive at 1/5. And the reason this is not correct is because these plots could be different sizes. And therefore, the sections of this plot will be different from the sections of this plot. So you can't actually say that each section is 1/10 of the entire garden. And so now I want to present to you with the correct solutions, and there are 2 ways you can think about it. And so I will give you a more by-the-book solution, and then I'll give you a less by-the-book solution. The by-the-book solution involves a little bit of algebra, and so I'm going to present that now. So I'm going to call this first plot here, I'm going to call that x. So this first one is x, and the second one is y. And so we know x plus y, the areas of x plus y, this must equal 1 garden. Okay? And now let's look at the area of the shaded region. So the shaded, which is the thing we're trying to find a fraction for, the shaded region is equal to, well, if we look, this red shaded region is 1/5 of the entire thing, of the entire plot. So this is equal to 1/5 of x. Likewise, this shaded region is 1/5 of y, since x and y are both divided into 5 equal sections, plus 1/5 of y. Alright, but now, look here, we have a 1/5 in each term, so we can pull that out. And so the area of the shaded region, this is equal to, if we pull out the 1/5, we then multiply that by x plus y. But remember, x plus y equals 1 garden. And so we can substitute that x plus y in for x plus y, which is equal to a garden. So the area of the shaded must be equal to 1/5 of 1 garden times 1 garden, which is equal to 1/5 of a garden. And so we arrive at the correct answer, 1/5, with a correct thought process. Now I want to give you an alternative way of solving the problem that is not algebraic, but rather geometric. So I'm going to pair each one of these sections up. So I'm going to pair these two, the 2 shaded regions, up with each other, and then going to combine this one with this one, and then this one and this one, and this one and this one, and this one and this one. Alright, and when I do that, I'm going to combine their shapes to make different shapes. So I'll show you what I mean. So if we take the first 2, the shaded regions, we'll have this vertical one and then a horizontal one. So it makes like an L shape. And we can do that for each other one, except they won't be shaded. So I'll color those in black. So here are the other shapes, and now there's going to be 5 pairs, so I'm going to draw 5 shapes. And all these shapes are going to be the same size. All right, and there are 5 pairs, all the same size. However, this shape, this first L shape, is shaded in, and it's one of 5 of these L shapes. So the shaded must be 1/5 of the entire garden because the shaded is 1/5 of each of these 5 shapes. So we have one shaded shape over 5 total shapes, which is again equal to 1/5. And so that is the correct solution with two correct reasonings for the garden problem. Kind of a change of pace, but there are fun concepts that can trip you up, and so I wanted to get this out there.